So seniors, let's see. This is your last week. So Friday's the last actual class day. And then finals are Monday and Tuesday, which means they're due Tuesday at noon. Because since you're graduating next weekend, we got to have those grades in by Tuesday afternoon so they can get all the final paperwork together to get you to graduation. Just like 3 or 4 days later, right? We just got a few days to get all of it together for all the seniors. So finals are due. The final will be available on Friday, actually. And they're supposed to send me a report on Friday to determine who is exempt, because you don't have to take the final in here if you're exempt. So whatever your grade is, come Friday after you turn in this week's assignment and any missing assignments, if you have any, could be your final if you get everything turned in. So let's go over the exemption requirements once again, just to remind everybody. You cannot have more than 4 absences in this class, or more than 4 tardies in this class. You cannot have more than 4 absences in your advisory class, which is coming up later today. Cannot have more than 4 in either class today. Or if you have more than 4 in advisories, you can't exempt any final. So you have to take all your finals. So that was the big one. You can't have any missing assignments. So if you want a chance at being exempt, you got to have all your work turned in. So any of you that have missing assignments, and again, there's not many seniors that have any missing assignments, but there are some. Not everybody's got everything turned in, which includes this week's. Right. So you can't have any missing assignments. Absences have to be 4 or less, and your grade has to be at least 75%. And just looking, there's not very many seniors that affects either. Generally, if you've got all your work turned in, let me look at this. Yes, everyone that has all their work turned in is at least a 75 in the class, and most of them are much higher. So that's not an issue. If you've got all your work turned in, you're going to have that 75% or higher. The only ones that are below 75 are some of them that have missing assignments, because there's nobody failing this class at all, and there's not very many people that are below 75%. So you guys are doing a great job. I think you're right here at the end. That's where you want to be. You want to be sitting pretty right here at the end of the year. So that's where we're at. But any questions on exemptions? I won't get the report to Friday. So Friday's when I email out the exemptions. So that's the same day the final will be available. A lot of you probably already know whether you'll be exempt. You know if you've been absent in here. You know if you have missing assignments. You know if your grade's over 75%. So it shouldn't be a surprise if you're exempt, because you've probably already been paying attention to that yourself, which is great. So, but that'll be sent out officially on Friday. And if I get the report any sooner than Friday, I will certainly get that information out as quick as possible, because I know everyone wants to make sure that you are officially exempt. And of course, now the great thing when you are exempt and your grade, let's say your grade's sitting at an 88.5, and you're like, man, if it was an 89.5, it'd round up, might get an A. If you're exempt, you can go ahead and take the final anyway. And if it raises your grade, I'll add it to your score. If it lowers your grade, I'll throw it out and pretend like you never even turned it in. Oh, yeah. So that's the greatest thing about being exempt, is it gives you options. If you're not exempt, you have to take the final, and it's going to count, whatever it does to your grade. But if you want to bump that grade up a little bit, you're so close, you can take that final, and it will only help you, will not hurt you. So you want to be exempt. All right, 7:22. This is probably everybody we're getting in class this morning, because if you're not here by now, you're probably not coming. But we'll get it fired up and see. All right, let's look at what's going on for our last week for seniors. Juniors, I will have more assignments that we'll do the next couple of weeks. Don't worry, I won't just leave you hanging. All right, let's. Oh, I didn't turn in my assignment last week. Mr. Fake Student is behind. Look, Fake Student has not got his work turned in. But for the rest of you guys that have your work turned in, we are on the very last lesson, the fundamental theorem of algebra. Fake Student's not going to be exempt the way it's going. Fundamental theorem of algebra, the very last assignment. So everything else should be, if you're not using this grade screen, by the way, and you're like, do I have any missing assignments? And you're looking in Hack trying to figure that out. This, for my class, is the best place to go. Go to this grade screen, not the activity screen. Go to the grade screen. And if you scroll down and see these zeros like Fake Student has down here, look, it's quick and easy to see. Oh, look, I've got 3 missing assignments right there. Now, this is a low assignment. That was a practice exam. See, that was a practice test, but it's turned in. It's not a 0. As long as there's no zeros. Now, if there's a 0 and there's a submission date, that means you turned it in and didn't get any points. That's not a missing assignment. But if there's a 0 and this is blank, like these are, no submitted date, these are missing assignments. So that's the best place to do is go to Buzz, scroll through here, and make sure nothing is missing. All right, let's go look at this last assignment that's on the board here. Fundamental theorem of algebra. I thought that'd be a good place to end the year at the fundamental theorem of algebra. Now, we did skip 8.03, and it had some stuff that I would love to have covered, but you may have hit that in Algebra 2. It had the real zero theorem, which you actually know a lot about it already. But the fundamental theorem of algebra says this. If f of x is a polygon of degree n, where n is greater than 0, okay, let's think about what that's saying. F of x is a polynomial. Okay, that means it has at least one term, could have more, of degree n. So it has x to the n power. X to the n power, and n is greater than 0. So it means it at least has an x to the first power somewhere in the equation. It could have a bigger one, x to the 4th power, x to the 9th power, x squared. But it has to be at least to the first power. Then f has at least 1 0. If n is greater than 0, it has at least 1 0 in the complex number system. Now remember, complex numbers means it could be an imaginary 0. It's possible. It has imaginary zeros, may not have any real zeros, but it's just saying the fundamental theorem of algebra says if you have a polynomial of degree n where n is greater than 0, it's going to have at least 1 0. Very, very basic, very simple. The linear factorization theorem. Let's talk about that real quick. That just says expanding this thought up here, we get the linear factorization theorem. It says if f of x is a polynomial of degree n, where n is greater than 0, f has precisely n linear factors. So, for example, a is the coefficient, a sub n, the first coefficient. X sub n plus x sub n minus 1 plus another term that has x down to the one that has just a constant. You can factor this into linear factors. That means factor down to where it's just an x. It's not an x squared, not an x. So it has exactly n factors. So that's saying if this is an x to the 4th degree, that's the largest exponent is the 4th degree, it's going to have precisely 4 factors, 4 solutions, 4 zeros. Now remember, some of those may be imaginary zeros, imaginary solutions, but if it's an x to the 4th, it's going to have 4 linear factors or 4 solutions. For example, if this was an x to the 4th, it would have 1, 2, 3, 4 linear factors that are just x. Notice that's not x to the n, that's just x. And C1, C2, C, etc. are complex numbers, and a sub n is just a leading coefficient. Examples. And this is stuff you know. So really, I chose kind of a review lesson for the last lesson of the year. A first degree, where it's like f of x equals x minus 5, is going to have exactly 1 0 because it's a first degree equation, and that 0 is x equals 5. If it's a second degree, an x squared equation, it will have 2 zeros. In this case, x equals 4 and x equals 3 are the 2 zeros for this x squared equation. If it's a third degree, x to the third, this x to the third equation right here has 3 zeros. One of them is -3, one's +2, and another one's +2. Look, it has the same 0 twice. So if you factor that, you would end up with an x plus 3, x minus 2, x minus 2. It would repeat multiplicity of 2. If you graphed it, you would only see 2 zeros because it would only touch the x-axis in 2 places, at -3 and at 2. But it does have 3 linear factors and 3 solutions. It's just one of them repeats twice. And for a fourth degree equation, such as this one, x to the fourth minus 16, it has 4 zeros, 4 solutions. 2, -2, 2i, and -2i. 2 of these are imaginary. If you graph that, you're only going to see 2 zeros. You're going to see a 0 at 2 and one at -2, but these will not appear on the graph because they are imaginary. But this is what the fundamental theorem of algebra and the linear factorization theorem says. Whatever degree this is, that's how many zeros it has. So I want you to find the zeros of the following. We'll work one of these together. Let's do x to the fourth minus 625. X to the fourth minus 625. And we're supposed to factor this to get down to the linear factors to find the solutions. So this and this, these are both square numbers. So this is a difference of squares. If you remember, we can factor with the difference of squares when it subtracts, and these are both squares. Because this is x squared times x squared. See, so that's a square number because it's x squared times x squared. And 625, this is 25 times 25. 25 times 25 is 625. So 25 squared, this is a square number. So that means the factors are x squared plus 25, x squared minus 25. Remember, we have that shortcut we could use to factor. And if we're finding the solutions, we're setting this equal to 0. Now, if we look at this, this is not a difference of squares because it is a plus, but this also is a difference of squares. So now x squared plus 25, and this is x plus 5, x minus 5, because this is difference of squares. So again, we can use the shortcut in factoring the difference of squares. So we're trying to get the solutions, the 4 zeros. So we've got to set all these equal to 0. X squared plus 25 equals 0. X plus 5 equals 0. And x minus 5 equals 0. Because we factored it as far as it'll factor. It won't factor any more than that. So now we set all the factors equal to 0. So over here at 5, x equals 5. That's one of our solutions. Subtract 5. X equals -5. That's one of our solutions. Solving this for x, we subtract 25. We have x squared equals -25. We just want x. So we're going to take the square root. So over here we have x. Over here, this is the same as the square root of 25 times the square root of -1. Because that's the square root of -25, which is not a number. But if we break it apart, we know this is plus or minus 5. It could be either one. And the square root of -1 is I. So our 4 solutions are -5, +5, negative 5i, and positive 5i. That's our 4 solutions. We knew there should be 4 because that was our exponent. So since the exponent is to the 4th power, we knew there should be 4 solutions, and that's what they are. Now, we should remember that we would expect to have 2 because they always come in pairs. This one would actually be 0 minus 5i if we wrote it out as a complex number. And remember, if you have this, you automatically have its conjugate, which is 0 plus 5i. They always come in conjugate pairs. The exact same solution, but one's negative, one's positive. So simplifying that is just negative 5i. Simplifying that is just positive 5i. All right, let's see what they have in our lesson on that on check your answers. This is factorable. X squared plus 25, x squared minus 25, which further factors, and they went ahead and put plus 5i minus 5i. So the 4 solutions, 5i, negative 5i, 5, and negative 5, just like we had. All right. On the other one, they did the rational zero theorem, which we actually skipped this month. But there's more than one way to factor that, right? It's a big old long nasty equation. We could actually just go to Desmos to find the real zeros. Let me see if I can just copy that. I'll have to fix it in Desmos. But all right, so this is to the 4th power. That is to the 5th power. That is to the 3rd power, and that is squared. All right, here is that equation. X to the 5th, 3x to the 4th, 5x to the 3rd, etc. If we zoom out, we see it makes a really big curve there, but there's 3 real solutions: negative 3, negative 2, and positive 2. So that means we could take x plus 3, x plus 2, and x minus 2 as 3 of the factors. That's 3 of the factors with the solutions in negative 3, negative 2, and 2. And you can use synthetic division for those 3 numbers and divide it into this great big long equation and find out what the last 2 answers are. Now, they're both obviously going to be imaginary because it does not show 5 zeros. It only shows 3. That means there's a pair, there's a conjugate pair as the other solutions. So you can do that. You can go through and figure that out by dividing out the answers we know from graphing it. So graphing polynomials. We use all the techniques to analyze and graph a polynomial function. So using the degree, and we've talked about that. If it's an even degree, it's going to go up on both ends or down on both ends. X-intercepts is the same solutions. The y-intercept, like on this, we know the y-intercept is negative 108. Because when you put x equals 0, all of this goes away. So we know the y-intercept and the approximate coordinates of the relative max and minimums. Like this has the max at about negative 2.5, about, if we took an approximate. So it has an example there on graphing that if you want to look at that. We don't have a graphing in this week's assignment, but this goes through an example. If you want to review that, especially if you're doing AP testing this week or anything crazy. Let's see, conjugate pairs. We just talked about that. If you have A plus BI, then you know A minus BI comes with it. Like example of 3 plus 2i is an imaginary 0. You automatically get 3 minus 2i. Buy the first one, get the second one free. 3 plus 2i automatically comes with 3 minus 2i. And that's always true. If you have a complex 0, an imaginary 0, you will then have 2 or 4 or 6, but they always come in pairs. They always come in conjugate pairs. And let's see, this is factoring polynomial. The rule concerning factors of a polynomial says that every polynomial that has a degree greater than 0 with real coefficients can be written as the product of linear and quadratic factors with real coefficients. Right? That just means you can factor it if it has real coefficients. All right, that is the end of the summary. This goes into more detail if you need to go back and read through the more detail, but really wanted to throw a lesson at you of most of the stuff that you've learned in all of your high school. You kind of know the fundamental theorem of algebra. You know if it's an x to the third, it's got 3 solutions. We've talked about that several times, but this has complex conjugate zeros, more detail on all that, all the way there. So we won't go over all the extra examples, but there's lots of examples down here and more detail. But this is just the bird's eye view of the lesson right here. Let's look at the assignment that we have for this week. The last assignment for seniors right here. Oh, yes, this is a good one. I'm going to put this on paper real quick. Write a polynomial function of minimum degree, which means it could be a higher degree, but if you add more in, but we're saying this would be the bare minimum, with real coefficients whose zeros include those listed, and write it in standard form. So it gives you 4 choices. And it gives you these zeros, a 0 of 8, a 0 of negative 14, and a 0 of 3 plus 9i. So I'm going to write these down as the zeros just to refresh your memory on how would you do that. And all your choices you see are x to the 4th. All right, so they give us these 3 zeros right here. And they said, all right, write an equation that would have these 3 zeros. So if it has a 0 of 8, you know the factor would be x minus 8, because 8 minus 8 is 0. If it has a factor of negative 14, you know one of the factors of the equation is x plus 14. So we'd multiply those together. That means this is x minus 3 plus 9i. Would give us this solution. But this is where you have to remember, what do we know about imaginary zeros? Since they gave us this one, we get this one for free. So that means there's another factor, x minus 3 minus 9i. So if you multiply these 4 together, you will get one of these 4 equations that's listed right there. And you look at that and you go, but Mr. Brock, that doesn't have any I in it. There's no imaginary. Interesting. There is no imaginary there. Why would that be? Well, let's go ahead and multiply these 2 together first. You can multiply them together in any order, right? 2 times 3 times 4 times 5. You can multiply whichever numbers together first. So we'll multiply these together. And then you'll have to multiply this and multiply this. So we have to distribute every term. The first thing we need to do is simplify the parentheses. This is a negative 1 outside. So this would be x minus 3 minus 9i times x minus 3 minus minus. So this is a plus 9i. So we've simplified by getting rid of the parentheses. Now we got to multiply x times all 3 terms, negative 3 times all 3 terms, and negative 9i times all 3 terms, right? We're distributing. So x times x is x squared. X times negative 3, negative 3x. X times 9i is plus 9ix. Okay, that's the first term. Now let's distribute this term. Negative 3 times x is negative 3x. Negative 3 times negative 3. Well, that's just a positive 9. Negative 3 times 9i is negative 27i. All right, all we have left to distribute is the negative 9i. So negative 9i times x is negative 9ix. Negative 9i times negative 3. Negative times a negative, so this is plus 27i. And then the last term, negative 9i times positive 9i, be negative 81i squared. Now we got to go back to our complex zero lesson we've had before. And we know that I squared is the same as negative 1 because it's the square root of negative 1 times the square root of negative 1. That's I times I, which equals just negative 1. So this is negative 81 times negative 1, or plus 81. That simplifies to that simplifies. So this is just plus 81 at the end. So now let's simplify this. We got a big mess right here. So let's see. We've only got one of these. So that's x squared. X terms, negative 3x and a negative 3x. This is an imaginary. We can't combine real numbers and imaginaries. So we have a negative 3x and a negative 3x. So we have negative 6x. We have a 9ix and a negative 9ix. Oh, look, those cancel each other out. Positive 9, negative 9. Let's see. We have a negative 27i and a positive 27i. Those cancel each other out. We have a 9 and an 81 plus 90. That's what all that simplified. Look, all the i's are gone. There's no imaginary part. So then you would multiply this times the x plus 14 and multiply it times the x minus 8. And since we have an x being multiplied by an x being multiplied by an x squared, you will end up with an x to the fourth equation plus all the rest of the stuff. So yes, you can take three factors like that. You know there's a fourth factor because you have an imaginary zero. You set up the linear factors, multiply them together, and you'll end up with one of those four equations they give you. Because the i's disappear. They cancel each other out. They become an I squared, which is just negative 1. So that's how you get started on that equation and come up with one of these four. All right, this one says state how many imaginary and real zeros. You're like, oh, I have no idea. Well, let me show you the easiest way to do that. Since we didn't go over Descartes' rule of signs, we skipped that lesson. If I delete this, and I'll take this and make this a Desmos graph. All right, there it is. X to the third minus 20x squared plus 123x minus 216. That's what they have there, right? Yep. I've got 3 real zeros. Well, this only has 3 zeros. So they're all real. If I didn't have 3 real zeros, I only had 1, like in this case, there you go. This would only have 1 real zero and 2 imaginary. So this one, they want you to write the factors. And notice both terms have an x squared that you could pull out. So what are the factors? And here's the last one, which is very much like our previous assignment we had. Do not make this hard. It says, using the given zero, there's the given zero, find one other zero. You don't have to tell me all the zeros. We know that there's 4 zeros because that's x to the fourth. I don't have to know all the zeros. I only need one more. And guess what? The one they give you is imaginary, which makes it very, very easy to find a second zero. If you know, oh, look, there's one imaginary zero, and then you remember something about conjugate pairs. It's something, just something about conjugate pairs. So don't make that easy. That's actually, don't make that difficult. That's actually a very, very easy one. Doesn't require hardly any work at all. You just write down the answer and say conjugate pairs. So, but that's it. That is our last assignment for seniors. Juniors, I got some fun stuff. I got 2 more assignments we'll do, and it's like project-based kind of fun stuff. So don't worry. You won't be bored the last couple of weeks of school. Juniors, our finals are in 3 weeks, right after Memorial Day. Tuesday, Wednesday, Thursday is finals week for us. Seniors, like I said, yours is going to be Monday and Tuesday, unless you're exempt. So, and it'll be available on Friday. So if you want to get it done on Friday and be done with school, yippee. All right, guys. That's all I got for you. Go enjoy your last week, seniors, juniors. We're almost there. Our last week is coming. But have a great week. I'll be here Thursday only because Friday is an A day. If you need help or got questions or anything. But thank you so much. Thanks, Kellen. See you guys.
What? Just ride. I just need a ride. Yeah. I just wanted a little ride. That's all I needed. Come on, Big D. Come on. What is it? What?
Painting.
I just wanted to go to the wedding. That's all I wanted to do.